Hi, everyone. Thank you for joining us for today's webinar. My name is Jonathan Hill. I am an engineer here at ATA Engineering's Northern Virginia office. And in just a second, I'm going to pass things over to Jason in San Diego for today's feature presentation, which is checking element quality in Simcenter 3D. Before we get there, I have just a couple quick notes to share with you. The first of which is that today's presentation is being recorded. It should be available tomorrow on our software website as well as on our YouTube page. So I'd invite you to check back at that time to watch the recording and share with a colleague. In addition, everyone's been muted for now just so that we don't have any interruptions during the presentation, but we will have a question and answer session at the end. And at that time, I'll change the settings so that you're able to unmute yourself and ask questions by phone. In addition, you can ask questions throughout the presentation at any time using the chat feature. Just note that we'll probably wait to come back to those questions until the end as well. So I'd also like to give just a quick intro to ATA Engineering. We're well known as a provider of high-value engineering services where we have expertise in design, analysis, and test. And we're really excited to help our customers overcome their product design challenges across a wide range of industries, some of which are shown here. In addition, we're able to leverage that expertise through our role as a value-added reseller and partner with Siemens Digital Industry Software, where we support a number of product lines, including Simcenter 3D and Simcenter Nastran, which we'll be talking about more today, but also others like FEMAP, Star CCM Plus, and more. We host a technical support hotline that's available from the beginning of the day on the East Coast until the end of the day on the West Coast, and you can reach that both by phone and through our software website. And then I also like to point out that we develop the official Simcenter Nastran training materials and are the preferred provider of Simcenter Nastran training in North America. Finally, I'd just like to invite you after the presentation today to check out our software website. We have a lot of great information on the site, from product brochures and information to our upcoming class training schedule. Probably my favorite part is the free resources that's available from the bright yellow button in the top right corner. And we have a lot of great content up there, including white papers, APIs, tutorials, on-demand webinars. There's a lot of really great stuff up there. So I'd invite you to check that out after the presentation today. With that, though, I'll go ahead and hand things over to Jason. Thanks.
All right, thanks, Jonathan. Hi, everyone. My name is Jason O'Neill, and I am also an engineer at ATA in our San Diego office. And I'm going to be talking to you today about element quality in Simcenter 3D. So just a quick outline of what I'll be going over. So this webinar will include methods to identify poor quality elements, ways to improve these elements in Simcenter 3D, and then lastly, I'll be going over a demo to show you some of these tools in Simcenter. So what's the motivation behind looking at element quality? Well, element quality is very important for producing high quality, accurate stress results and deliverables. But finite element models inherently have error because they're already using discrete finite elements to represent continuous real life bodies. And then if an element is of poor quality, these deviate considerably from equilateral shapes like perfect squares and perfect triangles. And this can further reduce model accuracy. So element quality can be quantified in a number of different ways, a handful of which are shown below, which can be aspect ratio, which makes your elements kind of long and stringy. Taper, which kind of does the same thing, but it skews one side to kind of turn your elements into parabolic shape. You can also have element warping, which is kind of hard to tell on this screen, but this refers to out of plane deviation. So if you have a 2D quadrilateral element, this happens when you start to kind of pull one node out of a plane. You can also check the interior angles. So the interior angles of like a square are 90 degrees, and for a triangle are 60 degrees. So when you start pulling on a perfect element, these angles tend to get larger or smaller. In that same vein, you can also have skew, which you start to kind of see here as a square turning into a parallelogram. And then lastly, you can check the Jacobian. Now, the first 5 that I went through are kind of easily visually to tell what's going on with them. The Jacobian is a little bit more ambiguous, but for the Jacobian determinant, for negative values that occur at a node, if the corresponding interior angle of that element is greater than 180 degrees, you end up with a negative Jacobian determinant. And I would just like to note then, if you have a negative determinant, your solution will end up failing. And then an example of a negative Jacobian determinant is when you have a square that starts to kind of look like more like a triangle. So that's what's pictured here in the lower right. So when it kind of starts to fold in over itself. And then another example would be if you have a triangle and it starts looking more like a straight line. Okay, so how do we check element quality in Simcenter 3D? So in your finite element model on the home ribbon, you can click on more in the checks and information section and then choose element quality under checks, and this will pull up the dialog box you see here on the right. So you can click on the pull down menu under elements to choose displayed or selected. And the only difference between displayed and selected is when you select displayed, Simcenter will automatically grab all of the elements that are currently displayed on your screen, whereas selected, you'll have to manually select the elements yourself, which can be useful if you want to grab just a small subset. Under checking options, you have the option to choose warning and error limits, or just error limits only. And the difference here is that warning and error limits gives you basically 2 levels of checks of element quality, and error limits can give you just 1. And the benefit of either, and it's kind of not straightforward, but in general, using error limits only makes things a little bit less ambiguous. And then skipping over general geometry checks is suggested under the solver specific geometry checks to check this box that is use element type specific values. And the reason for this is that to have Simcenter match or better match the solver element quality checks, because when you have the general geometry checks for Simcenter, it can be a little bit ambiguous what exactly the software is checking for element quality. So by checking this box, you have a more manual control of what you're checking. And you can change these values by clicking on this little taskbar button on the right here. And assuming that you have valid elements here selected, you can, by now, click on the check elements button, and this will populate a couple different things. First of all, NX will print whether or not there are elements that failed the quality check, depending on the options set here in the output settings. And then the failed elements will also be highlighted in the graphics window. And I'll also be going over all of this in just a moment here in the live demo. Okay, so managing element quality in Simcenter 3D is somewhat of an iterative process, but below here are some suggestions that can help improve element quality when creating a mesh. Generally speaking, you would want to avoid meshing very coarsely on small features, as something Simcenter can tend to do is smooth over small geometry by itself, which can, one, affect what you're intending to do at the small geometry, but then it can also affect all future meshes at this geometry, unless you end up resetting that geometry in Simcenter. But however, you can generally avoid this issue by setting the mesh parameters in the model cleanups options, which I have noted here, to a very low or 0 value. Then for 3-dimensional elements, a good representation of element quality can be evaluated by checking the equivalent 2D mesh on a surface. And this can be done by applying a surface coat to a 3D element mesh. And the reason that this should be done is because Simcenter generally has difficulty properly evaluating 3D element quality and the Jacobian factor, but it does do better with 2D elements. And then just generally speaking, having more control over a mesh can lead to better element quality, especially when you're dealing with more complex things. And a couple of examples of this is what I talked about before, some mesh parameters. Also adding mesh controls and having seed meshes are all good examples of having good mesh control. So in addition to checking element quality in Simcenter, you can also check element quality in Nastran. And this should be done in addition, not exclusively. So assuming that you have a solution solved, the .fo6 file will all list out poor quality elements. And I have a little tiny example here listed below. So on the top, you can see what the tolerance limits are for NX Nastran. And then below, you can see a list of all the elements that have failed, indicated by these 4 X's here. And then sometimes also you can see fail printed for elements that failed the element quality check. And then sometimes Nastran can flag elements that didn't get flagged by Simcenter. However, when I identified this solver specific geometry checks before, ticking this box can help avoid that. And then sometimes when you have a lot of elements, I think the default value for warning elements for poor quality is about 100 to 200. You can extend the limit to that by adding this command, geomcheck MSG limit. But generally, if you have a lot of poor quality elements that are getting printed at FO6, you may want to reevaluate your strategies. Okay, so what can we do about poor quality elements, assuming that your mesh isn't perfect? In general, it's worth spending time fixing bad elements, but in some cases, it might also be okay to leave the model as is. If the bad elements are in a region that you may not be interested in for stress results, or if there are just a few bad elements scattered across the mesh. A general good practice is to make a group of elements with poor quality. Visually investigating these elements can give you an idea of where the problem area is and then give you suggestions on how to improve things. And just a couple of suggestions of things to try. You can try changing the element size. You can try changing your meshing strategy, for example, free versus map meshing. You can try to adjust the underlying geometry by adding partitions or removing edges. You can also add mesh constraints. And then you can also manually move nodes or adjust elements if you need to. And then for larger models with multiple meshes, it's a good idea to check the quality of separate meshes before connecting them all together. Okay, so now I can go into the demo. Right, okay, so here I have Simcenter 3D version NX1872. And I have meshed here a relatively simple curved plate. And I meshed this plate with cutouts in it with 4 node quad elements. So the element quality tool under the home ribbon tab is all the way over here, at least for me. I actually have it set as a default here, and I think this is actually how it comes default for most people. But to get it specifically, you can go onto the More tab and then grab the element quality from the Checks tab. And this will bring up the dialog box that we were looking at before. So for this one, I will choose display since I have all the elements on the screen that I'm interested in. And then for my checking options, I'm going to just do error limits only. And then I will check this box here for elements type specific values. And then for display settings, I'll keep the default values. And then for output settings, I'll ask Simcenter to output the failed elements to a specific group. And then I'll also ask it to output a report for me. So here we can click check elements. So you can see here that this is the report that I asked for here. And then in this report, you can see the number of elements that failed and the number versus the number of elements that overall that were checked. And then below this, you can see all of the element quality checks that Simcenter goes through. And there's a lot of them here. So you can see all that here, and you can see the number that failed and the worst value on the opposing column. And then even below that, you can see a list of all the elements that failed and the reason for failing. So you can see here the parentheses E is the error. So it looks like a lot of these errored out in taper ratio. Okay, so I'll close this, and then, so another thing that I requested from element quality is I requested that the failed elements be sent to a group, which is automatically by default sent to this output group. So you can see here that it highlights all the failed elements, and if I do show only, I can get a swath of my only failed elements. Now it's kind of a little bit difficult to tell because this is a relatively small model, but on a larger model, it can be very useful to group your elements together and take a look at things. And then just to emphasize one more thing, so using the element type specific values, if I go into the list of things that are being checked, a little big, you can see here basically everything that Simcenter goes through to check all of the element quality. And by default, these should match NX Nastran's quality checks. And then just for an example here, I'm going to change the error limit for quadrilaterals on the taper ratio. I'll change this to 0.1. And basically this would imply that any element that's slightly tapered will get flagged by this element quality check. So we'll just double check this here. So now I'll keep all of my same options, and I'll hit check elements, and then you can see here that a lot more elements have been highlighted in the graphic window. And if I want to, I can show them as a group, and then that's a little bit more clear. So, okay. All right, so first I'll go back and switch to this value to its default. Okay, so there's still a couple bad elements in here, and I kind of want to fix at least some of these. So the first thing I'm going to try is reducing the element size. So I have it targeting 20 millimeters right now, so I'll try to shoot for 10. And sometimes when you go to mesh objects in Simcenter, you will get this warning that says elements in red violated Jacobian or warp threshold. And this is an indication that when you try to solve with this finite element model as it currently is, it will fail the solver. And you can see here, it highlighted the one element that's giving me issues. So that's something that we're probably definitely going to need to fix. But just to show you again how this tool works, here we can go to displayed, and I'll keep all my default values again, and I'll go to check elements. And our number failed is still 16, or has gone down to 16, I should say. But our number checked has went up a lot. So just as a general note, sometimes this isn't exactly a valid solution to all of your problems. But we can see here that some of the elements went away, but there still seems to be kind of an issue down here in this area, especially where that one failed element is. So another thing I'm going to try now is adjusting the underlying geometry. So I'll hide the mesh here, and then you can adjust the underlying geometry in the part file, but I will opt to go to adjust the geometry in the FEM by using the merge face command. So I'll remove these edges here. I'll let my mesh update. And I'll re-show everything. So you can kind of see the elements around here kind of conformed a little bit better to this area. And then now I'll do my element quality check again. And now we're down to 9 elements. And these 9 elements have been kind of persistent throughout the whole time, but I think it's also important to emphasize too that, again, not every single element needs to be perfect. You don't need to fix every single element. For example, if I was only interested in stress results in this area, then element quality in other areas may not affect as much down here as it would over here. And I think that's pretty much all I had. Oh, and then I guess one more thing that you could do, so in the nodes and elements. So one last thing that you can do if you really need to fix these specific elements is that you can manually adjust things. So there's a lot of tools to do this, and I'm not going to go through all of them today, but I will just quickly show. So like if I go to use a split shell command to split the shell in half to make them now two triangles. Check my elements again. Now we can see that that element went away, and now we're down to 8. But then I've also created two triangles in here, which can sometimes inherently be not as good as predicting stresses. So you might want to take that with a grain of salt. But yeah, I think that's pretty much it. I'll bring back the PowerPoint now.
Awesome. Thank you, Jason. So I've updated the settings. So at this time, we'd love to take your questions. Okay, well, I think we'll go ahead and wrap things up. Again, feel free to reach back out if you come up with more questions later on. Again, thank you, Jason, and thank you everyone for tuning in today.